We will solve this time the first 5 questions of SSC CGL solution set 13 on Algebra 6 from suresolve.com. This is Atanu Chaudhary. To solve these questions correctly, you need to be very clear about the basic concepts on algebra. Let's start solving the problems. Question 1 is the value of root over x minus 2 whole square plus root over x minus 4 whole square where x greater than 2 and less than 3 is option A 2x minus 6, option B 3, option C 2 and option D 4. In a hurry, you might choose the option A 2x minus 6 as the answer. To get this answer, you would form the result of the first square root as x minus 2 and the second simply as x minus 4. Adding the 2, you would get 2x minus 6. But would it be correct? Let's first make the three concepts of squares and square roots very clear. First truth of taking square root is you cannot take a square root of a negative value. For example, root over minus 16 is imaginary and we won't deal with imaginary numbers unless it is specifically mentioned. Second truth is the result of a square root function cannot be negative. For example, root over 16 is always 4, it cannot be minus 4. Third truth is when for a variable x square equal to 16, there would be two possible values of x plus 4 and minus 4. This is because mathematically, for a quadratic equation involving power of 2 of variable x, there has to be two values of x. In this case, we say when x square equal to 16, x equal to plus minus 4. If you raise x to its square again, the minus 1 with minus 4 is multiplied with itself twice to positive sign, and you would get a single value x square equal to 16. In our problem though, quadratic power is not there, but range of values of x is given. By the range of values, we have to ensure that after the square root is taken, the value is positive, simply because the result of square root cannot be negative. As x greater than 2, the result of the first square root will be x minus 2. It will be positive. But as x less than 3 less than 4, the result of the second square root will be 4 minus x, so that it remains positive. That's simple. You don't have to bother about any exact value of x at all. Adding the 2, you get x minus 2 plus 4 minus x equal to 2. X is just cancelled out. Answer is option C 2. You can solve this problem correctly within 10 seconds if you are clear about the square root concepts. Let's go over to the second question. Question 2 is if x equal to 10 to the power 0.48, y equal to 10 to the power 0.70 and x to the power z equal to y square, then approximate value of z is option A 1.88, option B 2.9, option C 3.7 and option D 1.45. This is a simple problem on indices and you would need two very basic concepts on indices to solve it. First is x to the power p whole to the power q equal to x to the power pq. The resultant power is the product of the two powers. The second concept is if x to the power p equal to x to the power q, then p equal to q. With equal base as x, the powers must be equal. In our problem, the first step we take is to substitute the values of x and y in the third equation. The result is 10 to the power 0.48z equal to 10 to the power 2 times 0.70 equal to 10 to the power 1.40. We have used the first concept on indices. The result has the basis on two sides of the equation, both has 10. The powers must then be equal by the second concept on indices. So 0.48z equal to 1.40. Or z equal to 1.40 divided by 0.48. We have to find the approximate value of z. Direct division is time taking. So we'll first eliminate the decimals by multiplying numerator and denominator both by 100. We get z equal to 140 divided by 48. Cancel out the common factor of 4 and simplify it to the maximum extent. Z equal to 35 by 12. Now we can easily derive the approximate value of Z mentally with minimum calculation. First quotient of division of 35 by 12 is 2. Next step division of 110 by 12 will be after decimal point and quotient will be 9 with remainder just 2. This will result in quotient 1 in the third step and we can ignore it by rounding off as it is less than 5. The approximate value of Z will be then 2.9. Answer is option B, 2.9. The third problem now. Question 3 is, if A by 1 minus A plus B by 1 minus B plus C by 1 minus C equal to 1, then the value of 1 by 1 minus A plus 1 by 1 minus B plus 1 by 1 minus C is option A 4, option B 2, option C 1 and option D 3. To solve this type of problems, the first thing we do is to compare the target expression to be evaluated with the given expression. We do this to assess how similar the two expressions are. From the result of this comparison, we decide what to do next. In this problem, we compare the first terms of the two expressions only, as the other two terms follow the same structural pattern. We find that the first two terms are very similar, and also discover immediately that by just adding 1 to A by 1 minus A, we would get 1 by 1 minus A. That is the key pattern discovery. Same will be true for the other two terms also. In total then, we would add 3 ones to 3 terms of the given expression LHS and also add 3 to the RHS. Let's show you. A by 1 minus A plus 1 plus B by 1 minus B plus 1 plus C by 1 minus C plus 1 equal to 4. Or 1 by 1 minus A plus 1 by 1 minus B plus 1 by 1 minus C equal to 4. Answer is option A 4. Again a quick solution, but this time by pattern discovery. Fourth problem now. Question 4 is, if x is real, then the minimum value of 4x square minus x minus 1 is option A 5 by 8, option B minus 15 by 16, option C 15 by 16 and option D minus 17 by 16. This is a problem of minimization of a quadratic expression and we will follow a simple standard method of minimization. Basically, we will convert the given quadratic expression into an expression with a component of perfect square of sum in x of the form a minus p whole square plus q, where p and q are the numeric terms and a is the variable. With the 3-term expansion of the perfect square of some component in x, converted form of 4x square minus x minus 1 would then be 2x whole square minus 2 into 2x into 1 by 4 plus 1 by 4 whole square minus 1 by 16 minus 1. To keep the middle term minus x unchanged, we got the value 1 by 4 of the second term of the square of sum. Square of this 1 by 4 is 1 by 16 and this is an extra term. Minus 1 by 16 is added to compensate it. The final converted expression is 2x minus 1 by 4 whole square minus 17 by 16. This is the form of converted target expression we wanted. Logic of minimization applied on this expression is, for all real values of x other than 2x equal to 1 by 4, 2x minus 1 by 4 whole square will be positive and will increase minus 17 by 16. Only when 2x equal to 1 by 4, 2x minus 1 by 4 will be 0 and value of the converted target expression will be minimum at minus 17 by 16. Answer is option D, minus 17 by 16. If you know the method of minimization, this is an easy problem. Last question now. Question 5 is, if 9 root x equal to root 12 plus root 147, then the value of x is option A 3, option B 4, option C 5, and option D 2. As such cannot be added numerically, you may feel a little confused for a moment. But then you discover that root over 12 is 2 root 3 and root over 147 is 7 root 3. Adding you get 9 root x equal to 9 root 3 or x equal to 3. Answer is option A 3. Solved in no time, but only if you discover the search pattern. Okay, here we end this session. If you want to read the solutions in the corresponding article in our website suresolve.com, use the link given in the description of this video. Thanks for being here with us.